Hi everyone, welcome back to our CSEC quadratics course, right? So in the last session, we would have learned about something called the perfect square. Now the perfect square is a special type of quadratic, right? The perfect square, right, is a special type of quadratic. Now, depending on what is your teacher's view on the perfect square, they may tell you that the variable inside may have a number attached to it, but I do believe that because there are ways around that, right? So generally, what the perfect square is if you have a quadratic looking, well, a quadratic in this form, sorry, x squared plus bx. Now you notice the coefficient of x squared is 1, x squared plus bx plus, now we know normally the next term is c, right? But the c term in this case is b over 2 squared, right? So if the perfect square is, so if you have a quadratic in this form, it could be factorized into x plus b over 2 squared. Now I showed how in the last video, right? So what we want to do now, this topic here is one of the most disliked topics in maths and add maths. I could tell you for over a decade a teacher now, I can tell you that this is hated far and wide, but it's mostly because a lot of times the students aren't really taught this technique because a lot of teachers tend to shy away from it, right? I will tell you that I like this technique. Now, there are two ways around this technique as well. I will show you them in later videos, but not right now. I want you all to know how to do the completing the square method. Now, it's completing the perfect square because what we are trying to do, we are trying to get a quadratic that isn't a perfect square to look something like a perfect square. So I'm going to show you examples immediately. Example. So complete the square. Complete the square. Right? So complete the square. 1 x squared plus 10x. So again, we want to make this look like this, right? And that's all you have to look at, right? What is missing from this, right? We have the x squared, we have the bx, but we don't have the b over 2 squared. So let's just bring that in. X squared plus 10x plus b, which is 10 over 2 squared. And now this is a perfect square. But you see, the problem with this is because this line is supposed to be equal to this line, I have misbalanced this expression. So check what I have to do. To rebalance it, I have to do the opposite of adding this number. So I have to subtract this same number here. 10 over 2 squared. Good. Now, this subtracting part is just a balance. It doesn't have anything to do with the perfect square. Now, up to the first three terms, look at this here. And these first three terms are of this form here, x squared plus bx plus b over 2 squared. So I can now write this as x plus b over 2, which is 10 over 2, 5 squared. And now outside here, I have minus 5 squared is 25. We done. That's it. This is all completing the squares, right? You just have to take your time and remember your perfect square formula, right? Let's go with number 2. But you have to understand where this came from as well. It's not just about learning a formula, right? Let's go with m squared. Now, when we say x, we mean any variable, right? So x squared minus 6, sorry, m squared minus 6m. So again, this looks something like this. You have the m squared term, you have the b term, but you don't have the b over 2 squared. So that's what we add on. We add on, because it must be plus b over 2 squared. But you can't just add on something, right? Sorry, let me write that back here. M squared minus 6m plus, yeah, b over 2 minus 6 over 2 squared. But you can't just add in a term. You misbalance the expression. So to rebalance the expression, you subtract that same term that you just added on there. Right? This way, the expression is balanced. This take away, this is 0. So you're just left with this. But what we have done here, we have enabled us to find this perfect square form. Let's see it again, right? And this now looks like this here, x squared plus bx, b is minus 6, plus minus 6 on 2 squared. So this could now factor into m, and what this number is inside here. This is, we just want the b over 2. We don't want the square to go inside these brackets. So minus 6 over 2 is minus 3 squared minus, and now negative 3 squared is negative 3 by negative 3, which will give us positive 9. But you have this minus here still, and this will give us 9 here. Be very careful with your negatives, please. You have to apply the power first. So minus 3 all squared is minus 3 by minus 3, which is positive 9, but they still have this minus here. So this is how it becomes subtract 9 here. And this is how we complete the square. Yeah. Now these are some relatively easier ones, right? If we go with, so I will stick with x for the most part because a lot of the questions tend to come with x, but I'll still throw in some random letters now and again. So let's go with x squared minus 12x. Right? How do we complete the square? We need to make it look like this first of all. We have the x squared, we have the bx term, but we don't have the b over 2 squared, the c term. So you add on minus 12 over 2 squared. But you can't just add this on, you are misbalancing the expression. So you subtract it to rebalance the expression now. The first three terms up to the added term, this is why we add first, right? The first three terms up until the added term only, that is the perfect square. So that becomes x plus b over 2, which is minus 6 squared. And now you are subtracting to my 12 over 2, well, minus 12 over 2 is negative 6. Negative 6 squared is 36, and you have this subtract here. So you get subtract 36. That's how nice and easy this is. Where the trouble comes in is where people start to panic and think here is when we have a fraction, but have no worries. I will guide you all through as I do with everything else. So I'm gonna write back the formula: x squared plus bx plus b over 2 squared is equal to, could be rewritten as x plus b over 2 all squared. Good. So let's go x squared plus 3. Let's go with x squared plus 3x. We want to complete the square of this. So we have the x squared, we have the 3x, but we need 3 over 2 squared. So x squared plus 3x, you add on that constant that we need there, 3 over 2 squared, but whatever you add on, you have to subtract it to balance it off. So it becomes minus, right, minus 3 over 2 squared. Now, the first three terms, as we saw from above, right here, x squared plus bx plus 3 over 2 squared could be broken down into these brackets or factorized into those terms, x plus b over 2, which is 3 over 2 squared. And now minus, so 3 over 2 squared, remember you need to know some powers and things for this. Anything squared is that something by itself. So 3 over 2 squared means 3 over 2 by 3 over 2. Now this is the only one in this I do in full, yeah? 3 by 3 is 9. 2 by 2 is 4. So this becomes 9 over 4. And we could leave it as an improper fraction for this particular topic. That's fine. Right? Let's go with number 5. Let's go with x squared minus 5x. And we want to make this into a perfect square like this. So look at the formula. X squared minus 5x, we have the x squared, we have the bx, but we need the plus b over 2 squared, right, to make it into a perfect square. You can't just introduce a new term, you have to balance off the expression, so you subtract the same term that you just added. Yeah? And now, the first three terms here, this, and this, oops, all add up to the perfect square. Right, these first three terms add up to the perfect square. So what we end up with is x squared, sorry, x plus b over 2 squared, whatever number is inside here, a half of b is minus 5 over 2 squared. Now, this was the subtract, sorry. Subtract minus 5 over 2 by minus 5 over 2. If you put that to the side there, try it for yourself, you will get positive 25 over 4, but you have the subtract still to give you just 25 over 4. Right? And this one is one of the more challenging ones. So I'll extra take my time with this one here. Let's go with x squared my plus. Let's go with 7 over 2x. So we want to complete this square. Right? Take your time, don't rush. Remember the formula. So we have x squared. B is 7 over 2. So you take b and you find a half of it. So a half of 7 over 2 is 7 over 4. And you square that term. All right, I'm going to put that on the side here. A half of 7 over 2 is 7 over 4. But remember, whatever you add on, you also have to subtract it. So it becomes 7 over 4 squared. The first three terms up to the added term is your perfect square. So this will now break down into x squared, sorry, x, right, yeah, x plus whatever number is in here, that number goes here. 7 over 4 squared. And this number outside here is take away 7 squared is 49 and 4 squared is 16. 49 over 16. Right? So this here was one of the more challenging ones. Right? Let's do our number 7. Right? It looks like I have time to do one more odd one like this. Let's go with x squared minus 3 over 5x. We want to complete the square on this. Good. Pause the formula there to pause the video, sorry, to rewrite this formula here. So let's see what this is looking like here. X squared, good. We have bx, b in this case is minus 3 over 5. So check what we do. We find in the side, you can find a half of minus 3 over 5. What this will give us is 1 by 3 is 3 and 2 by 5 is 10. So this is a half of minus 3 over 5. So remember, what do we do with that number? It will be x squared minus 3 over 5x. You are adding on a half of this number, which is minus 3/10 squared, but you are also subtracting that same thing that you just added on in order to balance the expression. Now, according to this formula, the first three terms, I don't know why my line function giving me so much trouble. Yeah, the first three terms are the perfect square. X squared plus bx plus b over 2 squared. So this now becomes, when I factorize it, x and whatever number is inside here minus 3/10 all squared. And now this just becomes, you're subtracting minus 3 squared is 9 and 10 squared is 100. Yeah, 310 squared is 100, and that's the answer. So this is how we complete the perfect square. And this is completing the square. Now, there are some slightly more challenging ones, which we will cover in the next video, when the coefficient of the squared term is not 1. But what I would love for you all to do, other than using the worksheets, you know, that I will send as well, try each one of these 7, one after the other. So go back up to the beginning of the video, pause the video on question, when you see question 1, try it for yourself. Yeah? See if it is you get through with it. And then try number 2 and do the same thing. Pause there to write down these steps for you, right? So find b over 2 squared as the first step. Add, then subtract it. The order is very important to the original expression. Use the perfect square formula, which is this, to make the first three terms up to the added term the perfect square, and the fourth one is simplify the external term. So in the next video, we'll be using this here and doing a little bit extra to complete the square on some harder ones. So until then, everyone, stay safe and see you all in the next video.